So sketching a graph, we have y is equal to x squared, x is equal to 2, and y equals 0 is the boundaries. Shading in that area, we can see this is connected to the x-axis, so as we create a 3D model, we can see there's no white space, so this is going to be a disk method. So we have volume is equal to pi, the integral from 0 to 2 of x squared dx. Then simplifying to get integral from 0 to 2 of x to the 4th dx, anti-deriving to get 1/5 x to the 5th times pi from 0 to 2, following the fundamental theorem of calculus, replacing in the value of 2, minus 0, so we get 32 pi over 5. The next problem, again, we're sketching the same kind of graph, so we have x squared, x is equal to 2, y is equal to 0. This time we're revolving around the y-axis, so it's creating the empty white space. You can see in the 3D model we have that white space inside of the bowl. So we're looking at a washer method, so integral from 0 to 4 of the outside radius, which is 2 squared, minus the inside radius, or the white space, which is radical y squared. So it's a pi integral from 0 to 4 of 4 minus y dy. Then anti-deriving to get 4y minus 1/2 y squared from 0 to 4. Then substituting in 4, take away substituting in 0. Following the fundamental theorem of calculus, we get an answer of 8 pi. This time we're looking at the solid that's bounded by y is equal to x squared, y is equal to 0, and y is equal to 4. So shading in that region. Revolving around the y-axis. We're connected to the y-axis. There is no empty white space, so this is going to be the disk method. Solving x in terms of y, we have x is equal to radical y, so our volume is equal to pi integral from 0 to 4 of radical y squared dy. Again, spinning around a vertical axis will work in terms of y's. So if pi integral from 0 to 4 of y dy, anti-deriving to get 1/2 y squared from 0 to 4, following the fundamental theorem of calculus, placing in the 4 and the 0, and get the answer of 8 pi. Looking at the area bounded by y is equal to x squared and y is equal to 4, this time revolving around the x-axis. Creating a 3D model of this, we can see there's some white space that's created. So this is going to be a washer method. So we have the volume is equal to pi integral from 0 to 2 of the outside radius. The outside radius is 4, minus the inside radius, or the white space that's created, so that's x squared. Then simplifying to get pi is the integral from 0 to 2 of 16 minus x to the 4th dx. Anti-deriving to get pi integral from 0 to 4 of 16x minus 1/5 x to the 5th from 0 to 2. Following the fundamental theorem of calculus, replacing in the value of 2 minus replacing in the value of 0. And then simplifying to get 128 over 5 pi. But we only did the integral from 0 to 2, but we needed the actual integral, or the volume, from -2 to 2, so we'll just double our answer to get the final volume, which is 256 over 5 pi. The next example, we have the same shaded area, so we're looking from y is equal to x squared, y is equal to 4, but this time revolving around the line y is equal to 4. Since that's connected to the y is equal to 4, there's no white space. That's going to be a disk method. This time we'll calculate the volume from pi to -2 to 2. And the disk, or the radius, which is 4 minus x squared. So the length of that radius is 4 minus x squared. Instead of anti-deriving from -2 to 2, we'll do 2 pi from 0 to 2, since we have symmetry. Distributing out the square, then anti-deriving. Then following the fundamental theorem of calculus, replacing in the value of 2, minus replacing in the value of 0. Then simplifying by getting common denominators. And then getting the final answer of 512 over 15 pi.